other Rife frequency. And at the end 20 MHz crystal. And carrier signal shape and frequency on the oscilloscope. Or other frequency, or lower. On the occasion of the upcoming Christmas and New Year holidays, visit the PCBWay Big Christmas Sale, where you will find discounts of up to 15%, as well as many other prizes and benefits. This project is sponsored by PCBWay. PCBWay is one of the most experienced PCB manufacturing company in China in field of PCB prototype and fabrication. They provide completed PCB assembly service with worldwide free shipping and ISO 9001 quality control system. Also, on their site there is an online Gerber viewer where you can upload your Gerber and drill files to render your board. So, if you want to make a PCB for your electronic project, PCBWay is a great choice for you. Visit their website and www.pcbway.com for more services. Hello, Rife machines are often promoted as devices that emit electromagnetic frequencies to destroy pathogens, including viruses and bacteria. However, these claims lack robust scientific validations. Royal Raymond Rife, the inventor of the Rife machine, claimed that it could treat various diseases by transmitting specific frequencies. In several of my previous videos, I described the principle of operation of these devices, as well as practical examples of making simple and advanced Rife machines. This time I will describe how to make a simpler version of the project do-it-yourself Advanced Plasma Rife Machine, but also at the request of several of my followers, I will describe the hardware part in more detail with given circuit diagrams. Namely, in the previously mentioned project, the part with the microcontroller, that is the oscillator, which is actually the carrier of the signal, is relatively complex to make for most self-builders. And this time I decide to make this part in a much simpler way with discrete elements. First, let's look at the block diagram of the Rife machine to explain the working principle more easily. As we can see, the components are carrier frequency generator, next generator of Rife frequencies. In this particular case, it is Frex16 software, which is free and is described in more detail in the previous video of this area. Next, modulator plus high frequency amplifier plus high voltage transformer, which serves to insert the Rife frequencies into the carrier frequency, and thus modulated signal is amplified and sent to the transformer, whose output produced a high voltage for driving the plasma tube. And at the end, the plasma tube that emits this signal into the environment, in my case blue argon plasma tube. Now we will focus mostly on the carrier frequency generator, because this is actually the difference between the previous device and this one. It's this little board, and this is the schematic of the oscillator. Although many Rife machines are sold in the commercial market not exceed 100 kHz, the original machine made by Rife has a carrier of around 3 MHz. This generator is capable of generating a carrier frequency in the range of 100 kHz to 30 MHz, depending on the filter used, unlike the previous time where we could change the frequency continuously. I currently have a 6 MHz, 14 MHz and 20 MHz crystal oscillator, and will test it individually with all three. Also, I placed a special connector on the board so that I can change the crystal quickly and without soldering. Another board represents an AM modulator with an amplifier, so the modulated signal thus obtained is fed to the high voltage transformer. This is circuit diagram of modulator and amplifier. The high frequency carrier signal is fed to the high frequency input, and the low frequency Rife signal, which is incorporated in the carrier, to the low frequency input. From the transformer, the high frequency signal is brought to the plasma tube, which then emits it into the environment. This is high frequency carrier input through potentiometer to modulator. Next, here go Rife signal low frequency input through potentiometer, also in the low frequency input. This transistor is power amplifier and high voltage transformer on the plasma tube, which secondary is connected on the plasma tube. And 12 volt 5 amperes power supply. Now I will demonstrate to you what the shape of the carrier signal looks like on an oscilloscope. First, this is 6 MHz crystal. And signal shape and frequency on the oscilloscope. Next, I will change the crystal. This is 14.3 MHz crystal. And frequency and shape of the signal, of the carrier signal on the oscilloscope. And at the end, 20 MHz crystal. And carrier signal shape and frequency on the oscilloscope. So we can place a crystal on the board with any values between 100 kHz and 30 MHz, and that will change the oscillating frequency. If we want to experiment with more carrier signals, we can install a mechanical switch that will change the crystals as well as the frequency of the carrier. The best way to test the functionality of the device is with a spectrum analyzer, and for this purpose I will use my SDR radio SDR Play with the appropriate software. This is the frequency of the carrier signal, 20 MHz, and we modulate that signal with a Rife frequency, which is clearly visible on spectrogram. Other Rife frequency. We will look at the same for other carrier frequencies. .3 MHz carrier, and now we will modulate this carrier with Rife frequency. For example, lower rife frequency, higher rife frequency, carrier modulated with rife frequency. However, very few do-it-yourselfers have access to a wide-range spectrum analyzer, so now I will explain to you the simplest way to test the functionality of this device. For this purpose, we only need a shortwave portable radio. In the way I will explain to you, you can test the functionality of this device, but also any commercial Rife device. First, we turn on the Rife machine and then the radio. Now on the radio we need to select the carrier frequency of the Rife machine. In our case it is currently 14.3 MHz. I will do that with auto search function. So the radio will be, should be stopped at 14.3. If we don't know, when we set the required frequency, the noise should be lost on the speaker of the radio. If we don't know the carrier frequency of an unknown device, we should scan the entire middle wave and short wave range until we get the silence, like in this case. So this is the carrier frequency. Now we need to connect a signal with Rife frequency to the low frequency input. In our case, we generate the Rife signal with the FREC16 software, which is always in the audible range, and we need to listen that frequency on the radio. So this is confirmation that device is working as it should and as intended by the creator of this machine. I will try with other lower Rife frequency, for example 146 Hz or 787 Hz or 1552 Hz. I will try the same with other carrier frequency. Now I will try the same with 20 MHz frequency of carrier. I will search for 20 MHz. There is hum, so this is not a carrier. Silent, and this is carrier frequency of 20 MHz. Now I'll put the Rife frequency with FREC16 software. Or other frequency, or lower. So this is functional Rife device. These beautiful light segments of plasma in the tubes is actually a visual presentation of so-called standing waves. And finally a short note and conclusion. This video only explains the technical aspects of this device, how to build it. It's important to note that many health claims associated with the Rife machines are considered pseudoscientific and their use may pose risks. Before considering any alternative or complementary therapies, including the use of devices like Rife machines, it's advisable to consult with qualified healthcare professionals and rely on evidence-based approaches. And my personal thinking about this device: at today's level of development of electronics, well-known companies manufacture CT and MRI scanners, ultrasound echo devices, and even sophisticated robots that perform precise surgical interventions. So imagine what these companies could produce if I myself, with my average knowledge in the field of electronics, can build a Rife machine for a few tens of dollars. According to this, if Rife's claims were true, there would be no incurable diseases today. Actually, the purpose of these few projects is that if you still believe in the functionality and operation of these devices, you can make them yourself or have someone make them for you for a moderate price, because commercial devices like this are sold at incredibly high, unrealistic prices. To give it a professional look, I mounted the device in a suitable box made of 5mm thick PVC board and lined with a colored self-adhesive wallpaper. And let me remind you once again, in order to make the whole process of making this device clearer, it is advisable to look at my previous works in Rife machines, the link of which is given in this text.